All right, so for class tasks today, I'm giving you the same file, Google Doc. And as I go over these, I want you to type something here, whether it's a reminder of what to do, something that you realize now. So as we go through this, that's what I want you to do. Okay? Because the thing about learning is sometimes it's a rocky road, right? You got to make mistakes in order to learn from them, and that's what's tough. It takes a little while to get used to that. Um, but if anything, improving is a good thing. Getting better at something is always a good thing. So I kind of pointed out this earlier. Now, I put this here because I wanted to, jog your memory. So we create these growth factors, okay, by adding to the one or subtracting from the one. So what got added to one here was 0.17. So that means this is a 17% increase. Because if we multiplied this number, the number is going to get bigger. Each time it'll increase by 17%. Whereas over here, we had to subtract from the one and so we didn't subtract 0.7 from the one, we subtracted 0.3 from the one. So this is a 30% decrease. Okay, over here, again, it's a little easier to see what got added to the one. The tricky part is what got subtracted from the one. So I'll point out another way to do number 4 when I get there. So what got added to the one? Well, it looks like 0.285, which is 28.5%. Okay, now number 4 is tricky because that's a very small decimal. At least number 2, it's a little easier to see that's 1 minus 0.3. Not so easy with number 4. So if you want, you could go ahead and solve an equation to do that. If you're good with numbers in your head, maybe you don't have to do this, but we know we got this by subtracting from the 1. So what's the decimal rate that would be? Okay? So you just solve that. Now, a way you can do this, I call that a switcheroo. I'm going to put that on the other side, and I'm going to put this over here. And when you do that, you change the signs. So you can go ahead and do this. So 0.995, which is 99.5%. Now that was the trickier one. So because of the small value, at least number 2 was a little easier. Okay. So again, the growth factor is what we multiply. You can, because like we were talking in the warm-ups, a lot easier. We create the growth factor by either adding to the 1. So this is going to cause a 17% increase every time we multiply, or subtracting from the 1. This is going to cause a 30% decrease every time we multiply. All right, I'll wait a moment. Again, I'm just pausing. I'm trying not to go too fast. Not, probably another 10 seconds, and we'll move on. Okie dokie. So now here's the exponential model. Now the R is the rate, the decimal percent. And so we would get this growth factor by adding, and the number we're going to add would be the number over 100 expressed as a decimal. Okay. And so when it's asking what's the growth factor, it's asking for what this is in parentheses. What is it that we're going to have the exponent to? It's asking for this. All right. So 1 plus 1.2 over 100. This expressed as a decimal would be plus 0.012. So our growth factor is this. Every time we multiply this growth factor, it's going to increase the number by 1.2%. All right, so that's the answer for number 1. Well, I think part A. Oh yeah, number 1. Sometimes I do A, B, C, sometimes I don't. Okay, so what exponential function would model this situation? Okay, so the model, the capital A means the original. So we started with 2,000. We're going to have our growth factor with the exponent. So we're going to have 2,000 times the 1.012, and then we have our exponent. So that's the exponential model. Now this exponent represents the number of years we have an increase, because this percentage that we used to create the growth factor was per year. So we want to find out how many years we're talking about when we answer number 3. All right, well, in the original 2,000 fish was 2015. 5 years later would be 2020. So the exponent is 5. Okay, 5 years later from 2015 to 2020. So that's this problem. Now, again, be careful. First, raise the 1.012 to the 5th power, then multiply 2,000. And if you want to check yourself, this is what you should get when you do that. All right, so I'll pause for a moment and we'll finish the last. All right, now the last part was why I did the warm-up, right? So that at least if you had an issue with that, maybe you'd have a fighting chance on the pre-assessment. Okay. So now I gave you the explicit formulas. And if we want to create a formula, which is what number 3 was, you leave the n as a variable. And so you need to find the constant difference, which you're adding or subtracting as you go to the right, and the first term, which, and okay, we're same thing here. You leave the n as a variable, you're looking for the ratio, common ratio, which is what you're multiplying as you go to the right, and then the first term. Okay, now again, just like the warm-up, there's no neither here. So you know one of them is arithmetic and the other is geometric. Or I could have been tricky and made them both arithmetic. But here, number one, you're adding 0.5 as you go to the right. So D is 0.5. Okay. And the first term here would be 17. So 17 plus 0.5 and then n minus 1 would be the formula for the first first sequence here. Now, if you wanted the term in the ninth term, then you just replace the n with 9. Whereas the second one here, there's no way you're adding the same number. So you know it's not arithmetic. Since you have only two options, it's got to be geometric. Okay, and then what are you multiplying as you go to the right? Well, it looks like 1.2. And so you could just take the second number and divide by the first number. You'll get 1.2, and we're starting with 100. So our formula would be 100 times 1.2, and then we'll have the n minus 1 power. And then again, to get the ninth term, we replace the n with 9. So then you just replace the n with 9.
I have a question.
What's that?
Is it number 1 or 2?
This is the third.
Okay.
3. Part of the instructions asks you to get the ninth term. So I'm kind of combining a whole bunch at once, right?
Okay.
First term, the constant difference, the first term, the common ratios. So the numbers that you need are already part of the formula. Okay, so the last two problems. Now the fourth problem here is me seeing if you even understand what that means. That's a symbolic way of saying for the sequence we're calling A, this is the 31st term. That's what this symbolically means. There's a sequence, we're going to call that sequence A. This means what's the value of the 31st term? Just like up here, we say the first term is A sub 1, which would have been 17. The first term is G sub 1, which would have been 100. And so if we went to the fourth term here, that would be G sub 4. If we went to the second term up here, that would be A sub 2. So this means the 31st term for a sequence we're calling A. That's what that means. Which means the n in the formula is going to be 31. Okay. And this is why we use symbols for math, because this conveys a whole lot of information if you understand what it means. Okay, now here I'm just having you replace the n with 10 and then calculate that. That's it. So knowing how to use this formula is also important. Right, so when you replace the n with 10, your exponent's going to become 10 minus 1. So this is going to be 1.3 to the 9th power, and then multiply 11.